So welcome to our third episode on creating an archaeology game with arcade.maincode.com. So where we left off last time is we've got our player, our archaeologist. He can move along our level and he can start digging through the dirt. We end up with a nice little disintegration effect as he digs up the dirt. So the next part of our game here is we need to be able to hide some fossils underneath the dirt for our archaeologist to find. So we want to make our game interesting. We don't want it to be the same every time. So we're going to use some randomness. And we're going to use a random number to work out how many objects the archaeologist should find. And also we want a random location for each of the objects so that they're never in the same spot. So to start with, we're going to have to try and create a random number that's going to be how many items the archaeologist has to find. So I'm going to come to my variables, and to start with I'm going to drag off my set block, and I'm just going to put it at the bottom here just after my last little loop there. Now I'm going to rename this variable, or I'm actually going to create a new variable, and I'm going to say items to collect. So this is going to be the number of items that our archaeologist has to collect. I don't want it to be 0, I want it to be a random number here. So I'm going to come along to the math category, and I'm going to scroll down and look for a block that's going to be about randomness. So this block here, it's a nice circle block. Pick random between 0 and 10. I'm going to drag that in, and I'm going to change it. So the minimum number of items that someone has to be able to find is 3, and the maximum they can find is 10. Okay, so I've got this variable. It's either going to have a number between 3 and 10 now. So what I want to be able to do is for every random number that has been picked between that range, I want to loop through and I want to create a sprite, and I want to put that sprite on the screen. So that sounds very much like a loop. So I'm going to look for my loop block here. I don't want to loop forever, but I do want to repeat this a certain number of times. Okay. And that number of times that I want to be able to repeat it is going to be the number of items that I want to collect. So what I'm going to do is I'm going to fill this circle here with my variable items to collect. So now this loop is going to repeat however many times the random number comes out to be. So it might be 4, it might be 5, it might be 10, it won't be 2 and it won't be 1 because they're not between that range. So now that I've got this loop here, what I need to be able to do is, just like I did for the dirt, I'm looking to create a sprite that I can place into a random location. So to create a sprite, I'm going to go to my sprites category, and I'm going to create a new sprite by using the top block. And I'm going to put it inside of my loop here. Now I'm going to rename this variable, and I'm going to call it a bone because I want this element to be a bone. I'm going to try and draw a bone here. I'll do my best to draw a nice little pixel art bone. And this is my interpretation of a bone. Clear that one out. Okay. And I'm going to set the category here. I'm going to actually add a new category, add a new kind, and I'm going to call it fossils. So I've got a bone, that's a fossil, so I'm categorizing it up. Remember, the categorization helps us when we come to do our overlapping to work out when two sprites have collided. All right, so just like we did last time, I've created a new sprite, and now I need to set a random location for our sprite here. Now I could do the same approach that I took last time and work out a random X and work out a random Y position, but it turns out that there's actually a really cool block that's already been created for us. It says place my sprite on top of a random type of block, and if I drag that in, I actually do want it to be able to drop into a random transparent tile here, because remember, our transparent tiles, if we have a look at our tile map, are all of the actual gameplay location there. So it's okay if it drops a bone or a fossil anywhere in those blank locations. That's actually what we really want. So I don't want it to be my sprite, because remember, my sprite is my player. I want it to be the bone. Okay, so what we're saying is we're picking a random number. That's going to be the number of items, in this case, number of bones that are going to get placed on the screen. We're going to go and repeat however many times our random number came out to be. Then what we're going to do is we're going to create a new sprite, set it as a type of fossil, and place it into a random blank location. Let's have a look and see what that looks like. Okay, so I'm digging around, I can see a nice bone just there, another bone over there, and a bone just there. So my random number must have came to 3 that time. Can't see any more. Hit refresh, test it again. Yes, I can see more. There's 4 there, there's 1 right over to the side, and lots down the bottom. Now that looks like it's working well. The issue I have is the player can see those bones because those bones are sitting above the dirt there. I'm going to need to hide that so that the game's a little bit more challenging. So what happens is when we add a sprite to our game, they just sit on top of the previous sprite. So what we can do is this code that we've just created, we can drag it off and we can put it above the dirt creation code just here. Now if I run that now, you'll find that the bones get placed first and then the dirt comes along and gets placed above it. So I can find my bones just here as I dig through, so it's much more of a surprise. Awesome, fantastic. So now what we can do is we can start adding some logic to try and take care of when our sprite is colliding or overlapping with a bone. So just like we did with our dirt particles, we can do the same thing with our bones. So I'm going to the sprites category and I'm looking for our overlapping sections here. And I'm going to just drag that down here. So you can kind of see what we had last time. So on sprite of kind player, when it overlaps with another sprite, we want this time, we want it to be our fossils. So when our player hits our fossils, we want some code to be run or some instructions to be run. Last time we destroyed the block. We probably do want to do something like that this time, but we also want to be able to keep account of how many bones or how many fossils our player has found. So if we have a look in the info section here, you see that we've got some scoring options. So we've got set score and change score. Now that sounds pretty good to me. So what I'm going to do is we want to be able to start with our score at 0. So I'm going to drag the 0 in under my on start. So I'm setting the score to 0 as the first instruction. That makes sense. We don't want our players to start with a score that's higher than 0. And what we're looking to do here is when we overlap with our fossil, what we want to do is we want to change the score by 1. Okay, so if I test that now, let's see what happens. Got to find a bone. Yep, there we go. And I can see when he hovers over or stays on top of a bone here, our score just keeps going crazy. Because what's happening is our bone and our sprite just continuously overlap. What we need to do is we need to be able to remove that bone from the scene, from the game, so that our little counter or our score only ticks over once. And the way that we do that is just like we did with our dirt sprites. I go up to sprites and I'm looking for the destroy block. And I'm going to drag that in. Again, just like last time, the fossil is what we want to be able to destroy. So I'm going to drag that over and clean up our little block there. So I'm looking for an effect that might look interesting for when we collect a bone. I'm going to maybe have a look at the confetti effect for maybe half a second. See what that looks like. So I'm going to bring my archaeologist down. Oh, I found a bone. I see the confetti effects kind of go off. And I can see that my score went up to 1 just there. Looking for another bone. Oh, there's one. Disappeared. Went to 2. So that's looking good. That's looking like it's starting to work for us. It's looking excellent. So at the moment, what we've found is that we can just play our game, and we've got plenty of time here to find all of the blocks. We can dig all over the level and we can find every single bone, and And it's not really much of a challenge. All we've got to do is just basically navigate our player around. What we want to have is we want to be able to set it up so that the player only has a certain amount of time to be able to find all of the bones and fossils. And if they can't find it in the allocated time, well, the game ends. But if they do find it, we'll move to another level and make it a little bit harder. So looking back in this little info category of instructions, at the top, where we just were, we've got the score, and we've got life. So think of a different type of game that might have a number of lives. So maybe you're Mario and you get hit by an enemy, you lose a life. That's the kind of scenario these instructions are helping us with. And the third category is our countdowns. So we've got a countdown. We can start it at a particular time, and we can end the countdown. We can have a block here that lets us write some instructions when the countdown ends. So let's drag the countdown end over and give ourselves some space. I'll move all of this down. So I've got a nice little hat block there for when our countdown ends. And I'm going to come back in again, and I'm going to set the countdown as my second instruction. So I'm starting the countdown. I'm going to give the player on the first level, maybe we'll make it a 30-second countdown. We're also setting the score to 0 here. So basically, they're going to have 30 seconds to try and catch as many fossils or find as many fossils as they can. When the countdown ends here, just for now, we're going to come along, look for our game category, and we're going to say, game over, you lose. Okay. Let's have a look and see what that looks like. I'm just going to change it maybe to 10 seconds for now, because otherwise you'll have to sit here for 30 seconds watching. So my game starts. I can see my timer has started at the top here, and I'm looking for as many bones as I can get in 10 seconds. I've only been able to find a couple, and my game has ended, and you can see here it's given me a score of 2 because it knew my score. It's actually because it's the first time I've played it, it's told me that it's a new high score. All right, so what we need to be able to do though is we need to be able to check to see if we've found all of the items and then make the game win. So we know that we're changing the score by 1 every time we find a bone. So what we could do is we could do a little test here, and we could see if our score is equal to the number of items that we need to collect. Because if those two numbers are the same, then we know that we've found all of the items that are on the screen, all of the bones that we've randomly placed on the screen. So to do that, we need to do a little test. We're looking for the scenario where if the score is equal to the number of items to collect, then the game has been won. So if we come over to logic, you'll see that we've got some of these conditional statements. And they kind of read the same way that we kind of want to describe the scenario here. So remember we said if the score is equal to the number of items to collect, then we want to win the game. So this conditional statement here is exactly what I want. I'm going to drag that over to my block here. This is my block where a player has found a fossil. So just after we've destroyed the bone, we're going to do a check here to see if our score is equal to the number of items to collect. So this variable is going to contain a random number, and that random number is going to be the number of items or number of fossils we've placed on the screen. So we need to compare things, two objects with an equal sign. I'll come back to logic, and I can see my two spaces with an equal sign, and it's also got these pointed ends which fit perfectly into our statement here. So it's starting to read almost the way that we're looking for if we want to say score is equal to items to collect. Well, I can come back to info and I can find my score here. I can drag that into the left-hand side, and my items to collect is red, so I know that's a variable. I'm going to find that variable and I'm going to drag it into the right-hand side. So now our statement's starting to read correctly. If our score is equal to our items to collect, then we can do something. What we're going to do is the opposite of our countdown end. So I'm going to come back again to game, And I'm going to say game over, and you win this time. And what we might do is add a little confetti effect as well. All right, it's going to be a little bit more challenging. I'm going to set my timer up, 30 seconds, and I'm going to try playing it. Okay. So I'm looking for all of my bones. I have no idea how many there are, but I'm just going to plow along and try and find them all. And oh, I'm running out of time, 15 seconds left. Oh, there was a bone. And there we go. I found both of the bones, so I win. Excellent. So our game is kind of starting to take shape now. So I think that's probably a good place to leave it for today as well. So what we've done today is we've created our fossils, we've placed them behind our dirt blocks, and we've set up a few game mechanics to be able to keep a track of the score and add a countdown so that our game becomes a little bit more competitive. Well, you keep coding and I'll see you next time.